Record. All right. Well, so we are in week 8 at this point. So, fall quarter is 11 weeks, but we lose basically a week over Thanksgiving. One class for us. So we're kind of coming to the end of things pretty quickly. I want to talk a little bit today about PA5, just to give you a heads up. I haven't posted PA5 yet, but I'll post that later on today, and then we'll talk about it in details on Thursday. But I want to make a few comments about that up front. Talk about last week's ODP 406, and then go over this week's ODPs, and then start talking about some other Unix commands, in particular the dialog command that you'll be using heavily for your final programming assignment. So let's start with any questions you have on anything first, including PA4 or PA3 wrap-up questions or things like that.
Since when did you have to have Zoom 4.12 to join this meeting?
I have no idea.
Or 5.12,
Yeah.
or whatever, because I had like 5.9.
Really? I don't even know what version I run. So I'm on Unix, and the Unix Zoom is always different. So it looks like I've got 5.11. And it says a new version is available, but I haven't updated because I won't do that until the quarter ends.
That explains it. I think I had 5.4. And it
Interesting.
needed 5.8 to join this meeting for whatever reason.
That's a little weird, but yeah.
It's never happened before.
Huh. Yeah, so maybe that was a few versions behind and they cut off at some point. I don't know. But yeah, I haven't changed anything knowingly on my end. So who knows? But you made it in, so that's good. Yeah, backwards compatibility only gets you so far. And at some point, a lot of times vendors will just cut off and say, nope, you got to update now. All right, so questions, comments, worries? How's PA4 working out?
Can I ask, is there a new line added after you read user input in Bash?
If you do a read, so yes and no, it depends how you're doing it. So let's just do some code. All right, so there's some simple test code to play with. So if I do just a straight read like this, when I hit enter, it will display a new line. Right, so name, I'll type in Nick. When I hit enter, it's echoing everything that I type, including the enter key, which echoes as a new line. And so it prints out my next echo statement on the next line, which is what we would normally expect. But if we do this business where we do an N1 to say, hey, just pick up one keystroke, then if I happen to hit an enter, it'll go down to a new line. But if I hit something like, an N, it will, echo the N, but there's no new line being echoed. And so my next statement comes out on the same line. So that's normal bash behavior. So in the high-low game, since they're going to type an H, an L, or a C without anything extra after that, the easiest fix is just throw an extra echo statement in like that. And now if I type my initial N, then it echoes a new line to get me down here, and then it does my output. And then if I happen to hit enter, I get 2 lines. That's okay. Don't worry about it. So as long as it's easy to read, and this is easier to read than that. So yeah, I would just throw an extra echo in.
So if there's like a blank space between our lines, you don't care that much.
Yeah, that's fine. It's not going to bother me.
All right. And what does the P switch do again?
Oh, P is a prompt. So it says print this message out and then do the rest of the read. So I could also have done, echo dash N name colon. And then done this read just the usual way.
Awesome. Thank you.
Yeah. Good. What else? So in PA4, we've got some sort of initialization in the beginning where we find out how many, what the range of numbers is that we're picking between. And then we have, a game loop, which looks like, see if there's cheating. And if there is, tell the user they're cheating and so on. Make a guess. Adjust your high or low based on what they did, or if they got the guess correct, tell them that they finished the game and so on, and then go back up to the top. So to count the number of turns, right, just initialize, number of turns equals 0. And inside here, every time that you make a guess, just do an increment. Like that. So num turns is num turns plus 1. And at the end, when the person says, okay, you got my number correct, then you can just print out the value of this variable. And this will basically tell you how many times you went through the loop. And each time through is another guess that you've made.
I kind of have like a random question, and it was just kind of something I was, yeah, and it's just something I was thinking about as I was coding this. I'm gonna try to ask this without giving like away too much. So basically,
Okay.
I like let's say that decision of it is it high, is it low, is it correct? We could say that's like made off of a variable that we'll call decision. Is it possible? Because I know the way we've been learning, it's like $sign that variable, equals whatever. Is it possible to set like, the CLH to integer values like C equals 1, H equals 1, and then just say like if decision equals like 1 or 2 or 3 based on what those integer values are?
You could do something like that, but not as easily as just seeing if the input was C, H, or L.
Yeah.
You could get into some interesting possibilities though. For example, we've talked about associative arrays, right?
Yeah.
So you could initialize an associative array with something like this. correct is 1, high is 2, low is 3. And then when the person types in a response, you could look up the value in this array keyed off of that response and get a
Okay.
1, 2, or 3 and do something with that.
Okay. I
But
actually
it
kind of
doesn't,
like
I
that
don't
way
think
better.
it saves you anything over just, if bracket, response equals H, that kind of thing.
Yeah. Yeah, it was just something I was thinking about. I didn't even think about the associative arrays, but yeah, it's pretty interesting.
Yeah. I think it
Cool.
makes your code longer, but it's kind of cool.
Yeah. Cool. Thank you.
Yeah. So as far as the cheat detection, so we talked about a way to detect cheating, and in that way that I described, we needed to do the check at the top. It's possible to detect cheating in other ways, and some of those ways might put the cheat detection at the bottom. But whatever, and you're not required to do it the way that I showed you, but you are required to detect cheating and have it act exactly the way it did in class. So for example, some things that can go wrong, if the person guesses, if the person is thinking of the number 100 and it guesses 99 and the user says low and it says, okay, you're cheating, right? That's a problem because 100 is a valid guess. If the user picks the number 1 and the program guesses 2 and the user says that's too high and the program says, okay, you're cheating, that's a problem because 1 should be a valid guess. If it gets to, it asks, is your number 35? And you decide to cheat, and so you say that's too low, and then it asks again, is your number 35? That's a problem, right? It should not ask the same guess twice. And as soon as you've done something cheating wise, it should notice it, right, and respond to it right then. So just make sure that all those edge cases work, and if it does, then you're good to go. All right, cool. What else? I'll talk about PA5 groups in a little bit. But short answer is, yeah, you can work with people in the other class. All right, so PA5 I'll post later on today. And that's going to be a group project if you like. So you'll be able to work in groups of up to 4 people. You can work alone if you like, but you can also choose to partner up with people. And it's also going to be a project where your group is going to present your program to the class the last week of the quarter. And so you should think about this in terms of, do you want to work alone or do you want to work with other people? Sometimes working alone is more comfortable for us, right? Because we get to choose how things get done, when they get done, and we succeed or fail by our own hand. But group work is going to increasingly be a part of your education, and then on the job, it's going to be sort of the norm that you're working with other people. So any chance to sort of get experience with that is probably worth taking advantage of. And this is an opportunity to get some group work. But if you decide you're going to work with other people, you should think about, number one, who do you want to work with? And, ideally it's somebody who you have confidence will be, a good partner, and will at least, make an effort. Now, you don't have to partner with the best programmer in the universe, right? Partnering with somebody who's not as strong a programmer as you can be a really good thing. It can really help you with, trying to explain some of what you're doing to the other person. It can definitely help the other person having somebody who knows a little more, has different strengths from them. But if you are working with somebody who's not going to show up to your team meetings, or who's going to, not begin the project until the day before it's due, or things like that, right? That's going to affect your grade as well as theirs. The project is graded with 1 grade per group. So if you do, 99% of the work and it works great, and the other person is supposed to submit it and they don't submit it, you both get a 0. So think about those things in terms of working with other people, and try to have an idea how you're going to split this project up. And what we do on this project is stuff that you are responsible for in this course. It's stuff you might see on the exam. And so I don't recommend, for example, saying, okay, you write the code and I'll add some comments and this other person will do the presentation, right? Because it's only the person who wrote the code who actually learns the material involved in this assignment. So one approach might be to have everybody in the group try to write the complete program, right? Make an artificial deadline that's, 4 days in the future. Everybody tries to write the program, and then you get together and you compare your code. And you take the pieces from one that are really good, throw out the pieces from another that don't work as well, and sort of put together the group's version of the program. And this way, everybody gets experience with the concepts involved. Everybody contributes to the final product, and you still get, the experience of working on a team. And you can try to use Git and make a shared repository that everybody in the group has access to, and use those kinds of tools. Or you can, each develop in your own area and just email code to one another when you want to share. It's totally up to you. And if you want, specific suggestions, or you want to get deeper into using Git as a team or something like that, let me know, and I'm willing to work with your team to go through some of the mechanics of that and such. But PA5 is more generally a very kind of open-ended assignment. It's going to have a lot of leeway in what you do and how you do it. And that includes, how you decide to put together a team and work as a team. So it's going to feel very different from the other assignments where, like PA2, I gave you exact function names and exact prototypes and told you exactly what they had to do. PA5 is going to be kind of the opposite end of that spectrum, where it's like, here's the overall goal, make it happen. And so you get a lot of opportunity to work on the design part. And so someone asked me in chat if you can work with someone from the other class, and the answer is yes. You just have to coordinate things. So the last week of the quarter, each group is going to have to present their program to the class. So for us in here, we'll do that over Zoom. For the in-person section, we'll do that in the classroom. So if you work with somebody from the other section, I only need one presentation. And so you would need to coordinate ahead of time who's going to do the presentation. And if it's someone from this section, you'll do it over Zoom and so on. I don't need everybody to participate in that presentation. I just need one person to do the presentation for the whole group. But, if you've got 3 people in the group and you each want to do part of the presentation, that's fantastic, because then you get some good experience presenting. So there's flexibility there.
And I assume PA5 is going to be done in Bash. Is that correct?
PA5 will be a Bash assignment.
Okay.
And it's going to involve making graphical user interfaces, which we're going to talk about today, using a command called dialog. And so it'll be a very interactive program. I think I'm leaning towards doing an appointment calendar program. And it's usually a pretty fun assignment. It's dialog is a cool command that gives you pretty quick instant gratification. It lets you create pop-up windows and things that the user can interact with a mouse and so on and so forth. So we'll play around with that in a little bit.
So basically, if we want to, we can do this whole thing by ourselves, or we can choose
Correct.
to team up with somebody.
Yeah, you can be in a team of up to 4 people, or you can work alone.
Got it. And the
And
team
it's-
basically gets a singular grade that everybody gets.
Exactly.
Okay, and only one person presents at the end.
Only one person has to present, but you can have everybody from the team present, or some people, or just one. It's up to you.
And is there a grade for the presentation?
The presentation is required to get a grade, so, but you don't get graded on the quality of your presentation or anything like that. There's a grading rubric for what the program has to do.
Gotcha.
But
Okay,
in
thank you.
order to get that grade, there's got to be a presentation. And that's
Okay.
mainly because you get a lot of flexibility in what your program is going to do, what features you're going to implement, and so on. And so it's hard for me to know what to test. So that's the other reason for the demonstration.
Okay, gotcha.
And so I'll post that tonight. That'll be due 2 weeks from Friday. So it'll be a 2-week assignment like most of the other ones. And 2 weeks from Friday is the day after Thanksgiving. I'm not requiring you to work on Thanksgiving. You can finish this on the Wednesday before Thanksgiving if you want. But I'm giving you the usual 2 weeks, making it due on a Friday morning. But yeah, that is the day after Thanksgiving, so you might want to finish it before then. All right, so I'll post that later on today, and we'll talk about the details of it on Thursday, because I know people are still working on PA4 this week. But let's go ahead and look at the one-day programs. So the one that was due last Friday was 406. And that was taking in a command line argument, or a runtime input, and then printing out a series of pipes next to it. And most people did this, something like this inside PA3. So my solution was just, read a number, initialize a loop variable, and then iterate in a while loop as long as I is less than the number. Print out your pipe with a -n to say don't put a new line at the end. And so each time this echo statement executes, you get another pipe appearing next to the previous output. And then at the end of that loop, we echo $num in parentheses. And the behavior of this will be, if num is 5, it'll print out 5 pipes without a new line. And then this last statement, echo $num in parentheses, will print out a $, the value of number, a $. And if you just say echo always puts a new line at the end. So I would get this exact output, and then it would move down to a new line. And there was some confusion where people tried to do things like this. And so you can try to print out that number in parentheses with a -n. And if you do that, it outputs this, but it doesn't put the new line at the end. And then if you say echo -e \n-e says, let's pay attention to escape sequences. So this becomes a new line. And so that prints the new line at the end. But anytime you do echo without a -n, like here, for example, the echo statement always prints a new line after it's done echoing. So that would actually output this. And so you get an extra new line at the end, which messes up the assess. So you could do an echo -e -n, for example. But it's easier just to not do this -n switch here. Just say echo $num and forget about all of this stuff. And just remember that echo always puts a new line at the end unless you say -n. So that was a point of a bit of confusion for some people. All right, ODP 418. So this is due tomorrow morning. And we're back to writing C functions here. So you're going to write a function named move. It takes in an array of characters and it returns an array of characters. And so this first argument is considered to be an input. It's a string that we're trying to process. And the output should be a string with the same length, but with the first letter of the input moved to the end of the string. So ELLOH should change, or HELLO should change to ELLOH. So it's like a rotate behavior. And this is surprisingly tricky to get just right. So let's look at how this plays out. So suppose your input is HELLO. So your input string actually looks like this. It's got 6 characters. The H is at index 0, the E is at index 1. The last character O is at index 4. And the string length is 5. It's the number of characters in the string, not counting the null terminator. And your goal in your function is to build an output string. And your output string should look like this. The first character should be the letter E. Second character should be L. The next one should be L. The next one should be O. And then this last character should be your H. And then this should still be a null terminator. So you're going to need some kind of loop. And your basic logic is going to be, right, output 0 should be input 1. Take that indexed 1 character from the input, copy that to location 0 in the output. Out 1 should be equal to in 2. Out 2 comes from in 3. Out 3 comes from in 4. And that copies the ELLO. And then we have this one kind of oddball case where out bracket 4 equals in 0. And then we need the null terminator. So in this case, those would be the things that we want our move function to do.
Can you
Go ahead.
just do that?
Only
Because-
if you know your string is the length of 5.
Yeah, because they're declared as car star, not an array of characters.
Well, you can index them with brackets, right? Even though it's a car star, that'll work fine.
The trouble is, like, if you accidentally get one bigger than the length of the string, you get a second.
Yeah, so if your string was supercalifragilistic, this will only do part of it. If your string is high, this will not do the right thing. So you need some kind of looping that's controlled by what the length of the input string is. But looking at a sample execution like this can help you figure out how you can try to code this up in a general case. And it appears from this that if string length is 5, we wanted to loop a total of 4 times instead of our usual 5 for doing like a string copy. And we copy input I plus 1 to output I. And then if string length is 5, it looks like we do out string length minus 1 and set that equal to input 0. And then out string length equals a null terminator. And so something like that will work most of the time. But there's some edge cases. If your input is X, your output should also just be X. Take the first character and move it to the last position. Well, that shouldn't change anything. And if your input is an empty string, your output should just be an empty string. And so if my string length is 1 or 0, the logic I write for doing this kind of looping and these assignments can start to fail. For example, if I say out bracket string length -1 equals in 0, and string length is 0, that's going to do something goofy. It's going to say out bracket -1 equals, and that's going to segfault or corrupt memory. So you got to think about your edge cases. Think about what you'll do with an empty string, what you'll do with a string containing 1 character, and what you'll do with a string containing 2 or more characters. And make sure you handle each of those cases. Also, don't modify the input argument. So this first argument is an input string. Don't ever change an input unless you're asked to. So in this case, all you're supposed to do is create an output string, right? Which is the input string with that character moved to the end. So don't change your input. Do all your editing on this output string. All right, and you can use the string length function if you want, but don't use any other string functions. So test your program, right? Write a main program, which we'll look at in a minute. And then once you think your program's correct, go ahead and build a test bed. So compile, if you call your function, if you put it in a file called move.c, gcc-o move makes an output file called move. This is your function. This is the test bed, which is sitting on the server. Link those together to get this executable program move, and then assess it with this command. And I can almost guarantee that if you just write this at your first attempt and you try to assess it, it probably will not give you full credit because there's edge cases. And so you're really going to want to write some test code to exercise what you're doing. And there's a variety of ways you can do that. But for example, you could say, let's make an output array. And I could say move hello, comma out. And then printf. Inside some delimiters like angle brackets, print your output string. And I should see angle bracket, ELLOH angle bracket. If I see extra spaces, if I see funny characters, if I see nothing, if I see a new line, I've got a problem with my move function. And now try, a single character. And print that. And now try an empty string and print that. And now try another non-empty string and print that. And if all of those tests give you good results, you can have pretty good confidence that your code is correct. And then go ahead and try assessing it. But remember, if I write a program that does this and I run it, say again? If I write a program that does this and I run it and it says ELLOH, and then I write a program that just does this, just test X, and I run it and it says X, and then I write a program that just does this, and then I write a program that just does this, each of those individual tests may work, but if I did all those tests in one program, they might fail. Because if you're dealing with null terminators, if you're dealing with uninitialized variables, what you do in previous function calls can affect what happens in subsequent function calls. And if my whole test program only calls my function once, I'm not testing it as rigorously as I might if I called it multiple times inside the program. If I forget to copy my null terminator and I just run a test with X, I might luck out and my modulated string might just be X. But if I make this call first with hello, and then I call it with X, and I haven't added an all terminator, my string is going to come out like XLLO instead of just an X. So this is a harder test to pass. And if you write a test program like this, you can make your move function, compile it, run this. If it's not right, you can edit your move function, compile, run, right? You've already got your test cases hardwired in this program. Makes it a lot easier to keep modifying and testing. Alternatively, I could make a loop that says, while one, call fgets to read in a line, or save it in some other string like in, and then call my move function, and then print out my output. And now I have a program that, when I run it, it will let me type in hello, and it should print out the rotated version. And then it'll let me type in, ABC, and it'll print out the rotated version and so on. But this is a little bit tricky, because remember, fgets puts a new line at the end of your input. And if my input at this point is something like HELLO new line, my move function will change this into the following ELLO new line H. And so when I print my output, I'll see something like this. And that may confuse me, but this is actually the correct output for that input. The other problem is I cannot test my move function on an empty string if I'm using fgets, because if I just hit enter, my input is not empty. It's actually got one character, which is a new line. So if I'm doing a test like this, before I call move, I might remove the new line from the end, so that if I say HELLO, I just see ELLOH. Another option would be I could use the command line arguments. I could make a test program called my test, and I could have a loop that goes through each of my command line arguments in argv, and one by one passes them to my move function, saves the result in out, prints the value of out. And now I could say my test hello x quote quote ABC, and this program would run 4 tests with each of those strings and show me the result. So yeah, it's just an ODP. The grade doesn't count, but you can do a lot with one ODP like this. You can do a lot of development of a test program. And, if you want to get better with C, if you want to get more comfortable with argc, argv, and with looping and with edge cases and so on and so forth, this is a great little exercise to work on. And it's, do a loop from 1 up to argc minus 1. And for each argv, pass it to move, take the output, print it with some delimiters. And that's, that's a midterm question, basically. So I keep telling people, write code, practice writing code, come up with sample questions, do exercises and so on. There's tons of opportunities for doing that. And this is an opportunity where, to get the ODP working, you could actually, spend some time writing a general test program, get some practice with command line arguments and so on, and have a good way to exercise your move function. And then somewhere down the road, if there's another ODP and you can do the same thing, right, you've got some experience with that. So just some things to keep in mind moving forward with these ODPs. So that's due Wednesday morning, and then Friday morning 419 is due. So this will open tomorrow at 8:05. And 419 is a different type of program. So this is a program that starts to get into the idea of state, having a memory. And so for 419, you're going to write a pair of functions, put and get. And the whole idea is if you call put with an argument, it saves that argument's value somewhere in memory. And it saves it somewhere that the get function can read. And so the sample use from a main program might be something like this. If I say put 5, and then I say I equals get, and then I say print I, that should print out the value 5. And if I say I equals get, and I print I, that should print out a 5. But now if I say, put negative 18, and then I say I equals get, and I print I, that should print negative 18. So anytime I call get, it should print out the last value that was put. So this is a function that lets me save a value to do something with later. And where do we save it? We're just going to use a global variable. So this is an assignment where you're allowed to use a global variable. And basically, put will just save its argument in this global. So how do globals work in C? If I have a function, and I declare variables inside that function, they're local variables. They only exist between here and here, and when my function exits, those variables disappear. But if I declare a variable outside of all of my functions, for example, up here, if I say int glo, that's a global variable. And I can store a value in here from any function below here, and that value will persist. So if inside here I say something like glo equals 7, that puts a 7 into this location. And even if this function exits, that 7 is still sitting in this variable. And if I come back in later on and I try to do something with the variable glo, as long as I haven't declared it to be a local variable, it's going to pick up this value. So that's a global variable. It's
So
basically declared. Go ahead.
sorry, I was gonna ask, is that variable you're talking about, the glow variable, is that, just to be clear, that's not stated in the main, it's like stated in between where main ends and in between where the function starts, is that right?
Exactly. Yeah.
Okay, cool, thank you.
Yeah. And you used to be able to use the keyword static for this, and I can't promise that static will work if you declare something inside a function. In particular, if you declare it inside a function, I don't think the scoping will let you access it from a different function. So I think you need to declare it outside. And if you do that, I don't think you need the keyword static. And so you're putting both of your functions into a single file. I suggest calling it putget. And so putget.c is going to basically have your global variable, your declaration of the put function, and your declaration of the get function. So you want 3 things in that file: the 2 functions you're creating, but also the global variable, and just declare the global before you declare any of these 2 functions. And then if your get function refers to glo, it's referring to that same global variable. So write your putget function. If you want to test it with your own main program, something like this, you can compile by, compiling your main.c with putget.c, save the output. And once you decide your function works correctly, build your test bed like this. So make your output function main, link the test bed function, and link your putGet.c functions, and then assess it in the usual way. So that's the executable program main, that's the source file putGet.c. All right, other questions on that? All right, good enough. All right, so let's do a 5-minute break. Let's come back at 10:53. And we'll start talking about the dialog command, which is what we're going to mainly use for PA5. So we'll do 5 minutes, come back, we'll start talking about that, and then we'll go ahead and we'll talk about, if there's time, something called regular expressions, which will be a next topic. So I'll see you back here in a few minutes. All right, welcome back. All right, so PA5 is going to involve making a program that's very interactive, something that the user has a conversation with to do something. Probably an appointment calendar program or a reservation system or something like that. So we're going to want to be able to create something better than just kind of a prompt on the command line that says, you know, enter your name, enter, you know, the date you want to travel, that kind of thing. We want to use a graphical interface. And so there's a command available on the server, and you can install it on your own Linux setups, called dialog. And dialog gives us very rudimentary ability to create GUIs, graphical interfaces. And so if you just say dialog, you'll get a short synopsis of the options for using it. And if you do man dialog to look at the full manual page, there's a lot more detail in here. And it can be a little brain numbing to go through all of this. So what I want to do here is give you a very brief introduction to some of the options available, just to give you an idea of the kinds of things that we can do with this command, and to look at some of the basic ways we're going to interact with it, how to capture output that it generates, and so on. And then I'll leave it to you and the people in your team to play with this and mess around with it and ask questions if you have questions, but explore and see what it can do, and then think about that in terms of designing your program for PA5. So most of these commands will have the form dialog, and then we can list some options, and then we're going to say dash dash the type of dialog we want to create, followed usually by some other options, and then followed usually by a pair of zeros. And these zeros are the height and the width of the dialog. And if you put in a size of 0, it says set the size automatically. But if I want to make a box that's a certain number of rows high and columns wide, I can specify that in here. Or I can make these -1s to say maximize the box. So we want to explore different types of dialogues. And the first one to look at is info box. And this is a way to display a little bit of information for the user. So I'm going to change my profile here because my colors come out really horrible if I use a black background with green text. So I'm going to go to a different color here. And I'm going to say dialog dash dash info box, hello world 00. And I get this, you know, blue background. I get a box with my message inside. It's got, you know, a bit of a shadow effect. It's got a border around it and so on. And that's all that does. Just a way to display a piece of information. And, you know, if I put a longer message in here, then my box gets resized accordingly. And if I wanted a particular height, I can make that first argument something like 40. And if I want a particular width, I could make that second argument something like 80. I guess -1s don't maximize. All right, so we'll usually just do 00. And this can be any string that we want. And remember, this is a bash statement. And so when we execute a bash statement, certain things happen. And one thing that happens is if we have something inside back quotes like this, bash will execute the thing inside back quotes as a bash command, capture the output, and then use the output in place of this back quoted string. So if I say info box, double quote, back quote, date, back quote, double quote, the date command will run. The string that's produced by that will get used in place of this highlighted section. And this will look like dialog dash dash info box, Tuesday, November 8th, et cetera, et cetera. And so I get a box that looks like that. And of course, I can do things like the date is, and put the date out there. I misspelled date, but you get the idea, right? Because in bash, if I said echo quote, the date is back quote date, right? What will we expect it to do? We'd expect it to say the date is and substitute this stuff in. So if I say echo, if I say dialogue and I put this string inside here as the thing that comes after info box, right? That says, hey, here's what I want to display in my info box. Does that make sense? Cool. And so because we're in bash, I could do something like date pipe into cause and put that inside back quotes. Right. And so now I've got an info box with a talking cow telling me what the date is. And this is where bash starts to look a lot more powerful than C. Even though C is, very low level, and we can do anything we want in C. I mean, all of this stuff is written in C after all. But from bash, we've got a single statement here that's able to do this. That's pretty cool. And so if we start writing a bash script with multiple statements like this, we can make a program in a few lines of bash that will do some pretty impressive looking interaction with the user. All right, so let's go back to our basic info box. So there's our hello world. So that's an info box. Another option is a message box. And that's almost the same thing, but it gives us an OK button. So it displays a message, but it's going to hang out there until the user interacts with it. So if you're trying to be interactive with the user and you want to say, welcome to such and such, click OK when you're ready, right? It lets the user control the movement through the program. So with these kinds of dialogues, I can actually come up here and I can click on the OK button, and that'll exit dialogue, or I can hit the space bar, or I can hit an enter key, and all of those things qualify as hitting the OK button. It's a little hard to see with these colors, but this O is a different color from the K, which means that there's a abbreviation available. If I just hit the O button, that'll also register as clicking that. Whereas if I hit the 9 button, it doesn't do anything, or the 8 button or the K button. So this is the usual way that we interact with old school graphics interfaces, right? So if you have a Raspberry Pi and you do raspi config, you get a dialog that looks very much like this. And you can move around with arrow keys and tabs and things like that. But you can also use the mouse. All right, there are a number of modifiers we can put. So these are all the different types of widgets we can create, and we'll look at some of these in detail. But these are the things we can use to modify the behavior of this. So for example, there's a -- title switch. And I think all these different types of dialogues will accept these switches. And I don't know if this will work after the 00. I'm going to give it a try here. So that does not work. So you need to put these switches before the type of the box. So here I'm doing the same message box, but I'm also putting a title on it that says important message. So now I've got this extra thing up top. And there's a number of modifiers we can have. For example, down here is OK-label. That says, what do I want to put in the label of that OK button? So normally the button just says, OK, but I could change it to something else and say, for example, dialogue -- OK-label proceed. And now when I run this dialogue, instead of a button that says OK, it says proceed. So you can do a fair amount of tailoring on these things. And these options work on most of the dialogues. And so you can play around with those, and you definitely should. You should explore those and see what they do. All right, but let's look at other types of boxes. So we got info boxes, we got message boxes. We can do a yes, no. So I'll do dialogue -- yes, no. Make a choice 00. So now I've got a box that I can choose one of two buttons. And I can use the tab key to switch between these choices. I can use the arrow keys to switch between these choices. I can use the mouse key to click one of these. So I can click yes, or I can click no. Or I can, choose one of these with the tab key or the arrow key, and then I can hit a space bar, or I can hit the enter button. Or I can use the hotkey that's highlighted. So for example, a Y for yes, or an N for no, and it will take that as my entry. So how do we know which button the user clicked? So for a yes, no, we can check this $? Variable. So remember, this is the bash variable that tells us the result of the previous instruction. It tells us the exit code for whatever the previous command was. And so if we run this dialogue and we choose the yes button and we echo $? we get a 0. If we choose the no button and we echo $? we get a 1. So sort of negative logic. 0 equals yes, 1 equals no. So let's start making some scripts. So we'll make a sample script here, and so let's wait for the user to be ready. So we'll put a dialog box out saying, are you ready? And when that exits, $, question mark shows the answer. 1 equals yes, 0 equals no. So if the person says that they're ready, $ question mark should be 0. So I'll set my ready flag equal to 1.
Can I ask, is there a reason you inverted the numeric kind of, because in the program it was like yes was 0, 1 is no. Is there a reason you inverted them here in your while loop?
Yeah, because I messed up.
Oh, okay. I thought maybe it was like something I wasn't like catching on to or
Nope,
something.
thank you.
Okay.
All right, so yeah, 0 is yes, 1 is no. So if $ question mark is 0, they click the yes button. And so set a flag showing user is ready. All right, so if they click the no button, $ question mark will be 1. We won't change ready. We'll come back up here. Ready will still be 0. So when we come down here, let's say clear the screen. And we'll say you are ready. And we'll just end our script right there. Am I on Linux? Yeah. All right, so let's make this executable. I'm in my ODP directory. That's no good. All right, so let's go ahead and run this. So it prints up a dialog and says, are you ready? And if I say no, it'll ask, are you ready? And if I say no, it'll ask, are you ready? And if I say yes, then it'll clear the screen and say, you are ready. Should say you are ready. All right, so that's just, adding some stuff around this dialog command. But the point here is this is just a bash command, right? It's just like ls or cat or GCC or anything else. And we can put it inside a script, just like we can put other bash commands inside scripts. And in this case, we're picking up the exit code, $ question mark, to figure out what button the user pressed.
I see. I think what's confusing me is you're using ready as kind of like a break statement, right? So you switch it to 1
Yeah.
and that's why it breaks. Okay. That makes sense. I was like, why does this break out of the
Yeah, so let me throw a comment on here. So we'll set that to 1. So yeah, we could have made an infinite loop and then just put a break in here. But a more nuanced way to do it is to loop, well, this flag is a 0, and then set it to a 1 when we want to exit. Same thing in the end, though. All right, so what else can we do? We can say dialog -- text box. Let me get a better test file. All right, so there's a nice test file. That's the first chapter of War and Peace. So I can say dialog -- text box. give it the name of a file, and a 00. And this will create a box that has, the contents of the file in it. And so if you want to display a bunch of information, instead of making a big, long dialogue statement that has a whole bunch of words, in quotation marks after it, you can read the contents of a file and display that in a little pop-up box like this. Tables, maybe. So there's a way to do forms, and I don't know how well forms work on this, but you can try that. But if you did something to create a table in a file and then use this kind of dialogue with a text box, that might be the easiest way to do that. And there's certainly tools for creating tables as a text file. All right, we can also do edit box, and that brings up a window, but we can actually come in here and move around and make changes. And we can come down and delete things and so on and so forth. And then we can come down and we can say okay, or we can say cancel. And doing this lets us make, edits to a file, but it doesn't actually change the file. So I can come up here and I can, delete a bunch of this stuff. And it's a pretty crude editor. And I can say okay, but if I look at my file at the end, the file itself has not changed. But there is a way that I can capture this edited version of the file and then do whatever I want with that inside my bash script. But this edit box does not actually change the file. So we can mess around with that safely. All right, calendars. So I can say -- calendar, pick a date, 00. And this makes, sort of the usual calendar interface. And I can use my arrow keys to change my month. I can use my arrow keys to change my year, or I can pick a particular date. And again, I can click on a date, so I could do April 21st, 2026. And hit the OK button to get out. Or, highlight the OK button and hit the space bar, or highlight the OK button and hit the Enter key, or hit the hotkey for an OK, which is an O, and so on. And when you do that, you notice that something that looks like the date appears in the middle of the window. So I've got an 8th of November 2022 that popped up here. And if I was up here and I click October 11th, 2022 and say okay, I get, 11th October 2022 appearing up here. So this is a different kind of thing. When I say -- calendar, after the user picks a date, the dialog program will print out that date on my screen. And so that's what we're seeing here is the output of dialog. And that's not a terribly useful or convenient thing to have happen, because I don't want to print the date. I want to take that date, put it in a variable, and then do something with it. Record an appointment for that date, or make a reservation for a flight that's leaving on that date, or something, right? I don't want it to just appear on my screen. So this is where our back quotes are going to work. So if we say back quote dialog, blah, 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 we can have our dialog program run, and then this output that it produces at the end, like this date string, we can save that in a variable. And we're going to have to do something just a little bit different. So there's a very particular syntax we're going to have to use. So this is going to look like the following. My date equals back quote, and I'll say dialog calendar. I'll put in a title. I'll put in my height and my width. At the end of this, I'm going to say dash dash output dash FD space 1 space 2 greater slash dev slash null, and my closing back quote. And this part is just boilerplate. This is something we're just always going to put at the end of our dialog command when we want to capture the output. And we don't have to understand what that does, but it's basically taking the standard error file output and the standard out file output and combining those. And so this is going to let us capture what this command would normally print to our screen. So if I do that and I pick a date like, November 24th, then if I echo my variable, my date, it's got 24th November 2022. And if I run this command again and I print, November 1st, and then I look at my date, now it's 1st November 2022. So this is a syntax that you should note and that we're going to see again and again and again. Every time that we use dialog and we want to capture output, we're going to do 2 extra things. We're going to add this to the end of the dialog command, and we're going to put the dialog command inside double back quotes, beginning and end. And then if we make variable equals all of that, the result of this command gets saved in this variable. Is that clear?
So that piece you have highlighted there is, sorry, maybe I'm not so clear on that. Can you explain that again?
The easy explanation is you got to do this.
Okay.
It makes it work. As to why it works, so if you look at the output FD switch, it says direct output to the given file descriptor. Most dialog scripts write to standard error, but error messages may also be written there depending on your script. So what we're doing here is, I believe we're changing standard out to go to standard error, or maybe the other way around.
Okay.
But in the end, it makes it work.
Okay, cool. Thank you.
Yeah. And we spent a while in class yesterday trying to figure out what was wrong with this, because I had this extra space after the 2. If you have that space there, it looks like it works, but it actually doesn't. So this is just more bash mystery, but you got to have that without the space. So I think this is sending the output to standard out so we can capture it with back quotes. And then it's sending standard error to dev null, so we don't see error messages, something like that. All right, so we can use this with other dialog options. So for example, dialog dash dash input box. And we can say, who are you? 0, 0. And this gives us a nice little 1-line input. So we can say, I'm Nick. And again, it prints a copy of our input to our display, which we don't really want. So I could say something like name equals back quote dash dash output FD 1, 2 greater dev null back quote. And now if I say, my name is Nick 12, and I echo $name, it's Nick12. So same syntax as with the calendar command. So input box lets you grab that input. Can you change background color and text appearance? There's some options for that. So the most significant option is based on what your terminal settings are. So for example, with a black background and green text, I get this lovely, blinding combination of fluorescent green on gray. And so one thing that affects it is the terminal settings themselves. So what your background and foreground colors are and what font you're using. But there's also some options in here related to color. And I haven't played with those. Those are ones you can mess around with. I don't know if it will let you play with font through the command line options. But I think you can do some color tweaking. All right, so we can modify our script. So wait for the user to say yes, and then we can say, instead of clearing the screen, get the user's name. So we'll do dialog -- input box. Who are you? And so this should display a box, ask who you are, capture the output, save it in name. And then we can say dialog message box, you are $name 00. So we'll do the usual dialogue we have before, where we wait for the person to be ready. We'll ask them their name, get their name, and then echo it out in a message box. So are you ready? No. Okay, I'm ready. Who are you? My name is Bob. And then it says you are Bob. And I can say, okay. So your final programming assignment is going to be, a number of calls to dialogue plus a bunch of bash stuff for doing whatever it is that you need to do. And dialogue is just one of the tools that you'll be using, but it's the main one you'll be using instead of echo and read, right? Echo displays information, read gets information from the user. Well, now we can do those things visually. Instead of having them type in a date, we can have them go through a calendar and click on a date, and so on and so forth. All right, so if you use PuTTY, there's a trick here. See if I can get PuTTY to work. I got to remember my password. Hey, there we go. All right, so really tiny little text here, but dialog info box, hello world 00. And by default, when I do this, my box comes out a little goofy looking. I get these Q's and X's and stuff like that instead of my nice lines that I get that make this look like an actual box, right? So this is a PuTTY thing, and we can fix this pretty easily in PuTTY. but I have to remember what this is. So under translation, enable VT100 line drawing even in UTF-8 mode. That's the box you want to check. And then if I go back here and I say Nick at Linux in grcs.com. Go ahead and log in. So now if I do my dialog command, I get the expected behavior of, you know, a box with lines instead of letters and so on and so forth. So depending on your terminal emulator, you may have to do something similar, but if you're coming in from a Linux system and you're running something like console, and you just SSH in, that should work fine. If you're getting weird behavior from PuTTY, like I say, go down to translation and check this box that says enable VT100. And remember, you can save your defaults by you know, load your default settings, change the options you want, and then come down here and just save under default settings. And different versions of PuTTY may make that setup already. This is an older version I'm running. But if it already works, that's cool. All right, other options. Dialog -- checklist. With, you know, some sort of title for the checklist. Height and width, and then a number of arguments that come after this. And so this is going to be a way to display a series of checkboxes with names next to them. And so, for example, I could say, you know, I want 3 checkboxes. Item 1, the 3 checkboxes. 1 is, you know, north, 2 is south, 3 is other. Oh, hold on. Checklist. Hold on. So I can say 1. Yeah, I'm confusing my commands here. All right, so 3 is the number of lines of checkboxes that I want. So I'm going to have a title like north, and then I can have a tag saying what I'm going to call that. So that might be N, and I can specify whether this should be checked or unchecked to begin with. So I'm going to say this is on, and then I'm going to do south S, and that'll be off, and I can do other, and that'll be O, and that's off. And so now I've got 3 lines of checkboxes. I can move between them with my arrow keys, and I can turn each of them on or off by clicking, or I can use the hotkey N to hop up there, and I can use spacebar or enter to toggle that. And then when I say OK, what I will get is a string containing whatever was in this middle column for the items that were selected. And so I can capture that and put that into a variable. And we're going to talk about some other tools in a little bit, like sed, that we can use to break this up and figure out which items were selected. So this is a more versatile way to get input from the user, where they could choose, you know, 0 or more options by just going down and clicking on different boxes. And if we do a radio list, it looks almost the same, except that if we choose any of these items, the other items get unchosen. So we can only choose one item at a time. And sometimes that's going to make more sense if you have exclusive options, then this prevents the user from choosing to go north and south, for example. And then whichever one you pick, that becomes the output, and we can capture that with the back quote business. All right, we can also do menus. So we can say menu, make a choice, 0, 0, and let's do 3 items. And let's say item 1 is start, item 2 is continue, and item 3 is finish. And so now we've got, a menu box. And again, we can scroll down and hit a space bar to choose one of these, or we can just use the hotkey. So if we want to say finish, we can just hit a 3 and say okay. And then the function outputs whatever number the person selected. And we could capture that into a variable and process it and so on. So you may not need all of these, or you may choose that you want to use some other types of dialogues, but that's sort of the general flavor of most of these that you're going to encounter. And like I say, you're welcome to dig into these, and I suggest spending some time just playing with these, right? So for example, you can do a password box. And it's just like an input box, but it doesn't echo while you type. And then when the person hits enter or says okay, the dialogue command will return this as its output value, and you can capture that inside back quotes. Oh, for the menu option, so this first number is how many menu items I have. And then it's just pairs, item number and text, item number and text, item number and text. So we could say password equals back quote, dialogue, this stuff, dash dash output, dash FD 1 2 greater dev null, back quote. And I can type in my secret password. And then if I echo my variable, it's got my secret password. And, reasonable password boxes don't echo while you type. That's like gravely insecure, because not only do you know how many characters the person's password is, but, certain combinations of letters get typed more frequently than others. Most people will type a TH more rapidly than they will type, an A followed by a P. And so if you look at the frequency with which the asterisks appear, you can start to make some guesses about what character combinations the person's typing. And if you correlate it with a video from behind of the person's shoulders, arm, and head movement, and when characters are being typed because you see an asterisk, you can do a pretty good job of figuring out someone's password just from seeing the asterisks appear. So, good password input box won't show you that information. But if you really want that information, you can say dash dash insecure. And now it'll show you asterisks as you type. The upside of that is, it lets you know that you're typing and that your program isn't hung. And most people are used to seeing asterisks or dots when they type. So if they're not seeing that, they're going to think that their keyboard isn't working, or they're going to type their password wrong or something like that. So you have options either way. So again, suggestion, play around with these. Look at some of these different options. The gauges are fun for, like, tracking progress. You can play with forms. Like I say, I don't know how well they work, but you can check them out and see if that does anything you like. And this is, if I just say dialogue, that just gives me a very brief overview. And I can do man dialogue and actually see more detail. So I can search for calendar and get down to wherever it mentions calendar. If I hit N to search again, I can find all the occurrences of calendar. So there's the actual paragraph or two talking about the calendar option. And for example, I can highlight an initial day in my calendar by putting the day, month, and year after the calendar. I can change the output format by saying --date -format. And how do I do that? Well, I can go back through the documentation and look for this string and see where it talks about that. So there's lots of information available. All right, any questions for now on that?
Can you combine multiple menus into one screen?
Possibly, but I have not had much luck with it. And there's an option for doing that lets you move from one to another or put multiple ones up, but I haven't had success with it. Yeah, this and widget. Mess around with it. There's also tons of online help for this. I mean, if you just Google, dialogue calendar, you'll find some good use examples and so on and so forth. And Googling to try to understand bash commands, that's totally legitimate, right? That's not like Googling, how do I write a high-low program in bash? Use online resources to see how to use these commands or other commands. That's a good use of Google Stack Overflow, things like that. Just don't use it for, how do I write a reservation system in bash using dialogue, because you'll probably find code for it, but you don't want to do that. All right, so let's talk about regular expressions. This is a different topic, but it's related to some of the things you'll want to do for PA5. And it's a big part of working in a Unix environment. And so it's something that'll come up a lot. And so that's part of 224 is learning about regular expressions. So if we go into VI, and we edit a file, we can search for things inside VI by using a slash, right? So let me get a bigger test file here. All right, so I got a big test file here, 63,000 lines. This is War and Peace. So we can search for things in this file by typing a slash. So if I do a slash and I search for the word war, it will take me to the first occurrence of the pattern WAR. And in this case, it wasn't actually war, it was WAR followed by the letter N. All right, so I can search again. And beginning with where it was, it will look for the next occurrence of the word war. So there's the word war. And if I just hit the letter N, it will keep moving down to the next appearance of this pattern. And it doesn't know if I'm typing the word war, if it's WAR in the middle of toward. So slash some sequence of characters just looks for that sequence of characters. And so that's an example of a regular expression, but it's a really simple kind. So we can just have a pattern of characters and search for that, but we can do other things. So if we put a period in our pattern, that's a wild card. And that will match any single character. If we have a caret, that's what we call an anchor. And it matches the start of a line. And a $sign is an anchor for the end of the line. So what does this mean? If I search for caret war, I'm only going to find a pattern where there's a line that begins with the letters WAR. For example, right here. And if I were to search for WAR $, that'll look for a line that ends with that pattern, such as right here. So we have these anchors. So if I search for a dot, it's going to find this A because that matches a period. And if I say N to search for a dot again, it's going to find the letter R because that matches a period. And if I search for a period again, it's going to match this I. So a period matches any character, which by itself may not be incredibly useful. But for example, I could search for a space followed by 3 periods followed by a space. And this will match any 3 characters surrounded by spaces. So if I search for that pattern, it finds the word God, space, G-O-D, space. If I search again, it finds how, and then it finds the word not. Now it didn't match why because this was a space followed by 4 characters followed by a space, but not matches our pattern, space, 3 characters, space. All right, an asterisk preceded by some P matches 0 or more occurrences of whatever we put before the asterisk. So let's say I want to look for, I don't know, 2 occurrences of the letter N, right? I could just search for NN. And it'll find, a pair of N's right there. But if I wanted to look for 2 or more occurrences of the letter N, I could search for an N followed by N asterisk. So, well, let me look for an NN followed by 0 or more occurrences of an N. I don't think I'm going to find 3 N's in here. But I can make them appear. So now if I search for that,
You're searching for 2 N's or
I'm searching
more.
for 2 N's, yeah. So if I wanted to find 3 or more, I could search for that, and there's the N I just added in the middle. So where might we do this? So let's look for 2 or more dashes. So I can look for 2 dashes followed by, any number of dashes after that. And it'll find 2 dashes like that, but eventually it'll find those 3 dashes. All right, so that's a way to do repetition. So we can find better examples of that with the following. We can say, for example, A, E, I, O, U inside brackets. And this will search for any of these characters. So if we just want to find the vowels, we can say slash bracket A, E, I, O, U. And it will show us our next vowel. And if I hit N, it'll show us the next vowel after that, and so on. And if I put a caret in the beginning of this, that will negate the search. So it will search for things that don't fall in this category, things that are not the letter A, E, I, O, or U. So that would show me my consonants. So there's a D and a space and an F and a space and an N and a pair of L's and an N and a C, and so on.
Would it match capital E, for example?
No, so this is all case sensitive. So if I come down here and I look for the letter P, it'll skip over Pierre and just find that one. Now in VI, I can make VI case insensitive by saying set IC for ignore case. And then if I search for a P, it would find the P in Pierre. But by default, all of these regular expressions are case sensitive. So these brackets, I can also do things like say bracket A-Z or bracket 0-9 and so on. And so if I wanted to find a number, I could do something like slash bracket 0-9, and that'll take me to a number. And there's an 8 and a 2 and a 3 and a 4 and so on. If I want to find a multi-digit number, I could say, let's look for 0 through 9, followed by any number of digits afterwards. And so that finds 1805. If I search again, it's not going to go on to the 8. It's going to go down to this next string of digits. And then if I say next, it'll take me down to the 11 in October 11th, and then the 1805 and so on. So this is a more complex pattern. This is looking for at least one digit followed by any number of digits right after. And then the last thing we want to know is a backslash, which is an escape. So suppose you want to look for a period, right? If I just say slash period, it's just going to match the next character because period is a wild card. But if I'm actually looking for a period, I can put a backslash in front of it. And that says, hey, look for exactly a period. And that takes me to, you know, my punctuation mark period. And it finds me each of those in my file. All right, so this is a tiny little piece of the world of regular expressions, but it's a big enough piece to do most of what we're going to have to do in this course. It's most of what I've done in my own, you know, probably 4 decades of using regular expressions is just these kinds of things right here. So you can buy a whole book on regular expressions. You could probably take a short course on it, but this is enough to do most of our searching. And this may not seem terribly useful yet, because searching is only part of the story. But we can do a lot with this anyway, by using a command called grep. And grep is a way to search a file for a pattern. And in particular, we can search for a regular expression. So if I just say grep war in this file, it will go through the file and look for any line in the file containing this pattern. And if it finds it, it'll print out that line from the file. So here we can see all the lines that contain war somewhere inside them. And if I wanted to make this a little more specific, I could search for the word war surrounded by spaces. And now I've, only got lines that actually have the word war separated by spaces. But if the word war followed by a comma appears, I won't see that because a comma is not the same as a space. So I could search for a war followed by anything that's not the letter A through Z. And so that will also include things like war, comma. And so grep is an interesting way to search for information in a file. And one thing that grep does, besides showing us each line that matches our pattern, it sets a value for $?? And $? will be equal to 0 if grep succeeded in finding what we looked for. So if I grep for bunny inside War and Peace, bunny doesn't happen to appear. And now if I look at $? It's equal to 1. So if I want to know, does a file contain a certain pattern, I can use grep and then just check the value of $? One problem here, though, is that, if I search for something that is in my file, I get a whole bunch of output produced to standard out. And I may not want to see that in the middle of my script. So what we can do here is redirect this output to a special file called /dev/null. And dev null is what we call the bit bucket. It's a file that you can write into, and whatever you write into there disappears. So in this case, I can run my grep command to search for this inside data, but I don't see any of this spurious output being generated. But I can still look at $? and say, hey, war did appear in my file. Whereas if I search for bunny war, and then I check $? I see a 1, it says, oh, there's no bunny war in that file. And dev null, you can always use it. You can do anything you want with it. You can write anything you want into it and it just disappears. If you try to look at the contents of it, it's always empty. So if you try to read from it, your first attempt to read always returns end of file. And it's useful when you have output you don't care about and you don't want to see, you can just send it to dev null. All right, grep has 2 switches that I want to point out to you. If you say grep dash, so the normal use is just grep, pattern, and file. If you say grep dash I, that says ignore case. So if I say grep dash I war data, this will include lines that have an uppercase war in it. And I don't know if I have any of those in here. There probably is. But if there was an uppercase W or an all uppercase war, that would also appear. And then grep dash V reverses the search. So show me lines that don't match my pattern. So if I say grep dash V war, that shows me all the lines that don't have the string WAR inside. And there's a whole lot more of those, right? So conscious does not contain the word war. In the first case, it was necessary to renounce the consciousness of a does not have the word war. So grep dash V shows you things that don't match the pattern. Grep by default shows you things that do.
So it seems like if you're trying to search just whether or not something does exist in a file, it seems like this is kind of a bit taxing on the computer because you really only need it to find one and then finish.
Yes.
So is there a way to make it lazy or?
There's probably a switch for that, but if we're doing bash, we're taxing the computer anyway.
Right.
Bash is generally going to be pretty heavy-handed, but most likely there's a switch to say, do the first n matches, and And we could set that to 1. And let's see if we can find it. So V inverts I ignores cases. Count is not exactly what we want. Stop reading after num matching lines. So we could do dash M1, and then it would just give us the first line, I believe. So there you go. So that would help with saving, the load on the CPU. But if I really just wanted to see the first line and I didn't know about the dash M switch, I would do something like grep war data and pipe that into head 1. And head says, hey, take standard in and just show me the first line. And that's a really useful command. And there's another command tail, which will show us the last line. So if we wanted to see the last matching line that contains war in this novel, we could do that. Which was actually just toward, not war. So a general comment here about Unix commands, suppose you wanted to ignore a case and find things that don't match your pattern. You could say grep-i-v. But most Unix commands let you abbreviate this, in this case, as just -iv. And that means do a -i and do a -v. And so you've probably seen me do this a number of times, ls-lrt. So L says I want a long listing, R says I want a reverse order on my output, and T says I want to order by timestamp. So if I do an ls-lt, it goes from most recent to least. If I do an ls-ltr, it changes that from least recent to most. And I do this when, I want to see some file that I just created. I can't remember the name of it. I just do an ls-lrt and my most recent file is at the bottom. And I could do it as 3 separate switches and it does exactly the same thing. I could do it if I wanted as, -l-rt and it does exactly the same thing. So the general rule with bash commands is if I say, dash something, it's the same thing as just saying dash all of those things together. But most bash commands also have long options, and a common one is, for example, help. So if I say ls-help, how does the ls command know whether I'm asking for help or whether I'm doing ls-h-e-l-p? So these longer commands are always prefixed by 2 dashes. And so if you look at a manual page, like for grep, you'll see a number of options that have a single letter and they're prefixed by a dash, but there's also options that have multiple letters and they're prefixed by a double dash. And the double dash tells the command, hey, this is not 4 options, H-E-L-P, this is just 1 option. And most of the single letter commands like -i also have a longer, more descriptive option, for example, -- ignore -case. So if you don't want your bash program to have lots of cryptic looking switches on your commands, you can use these long versions of commands and say, for example, -- invert -match instead of just -v. But if you're typing on the command line, you're trying to do something quickly, you don't want to type grep -- ignore -case, right? You want to just do grep -i. So you have choices. And most Unix commands give you these pairs of options that you can choose from. So I've been grepping for a long time. Grep -i to me means ignore case. -v means, complement the search parameter. And so if I write my own code and I see a grep -i, it doesn't confuse me. But if you're trying to learn how to use grep, you might want to say -- ignore -case. Makes it more descriptive and so on. So that's not just dialogue, that's a general comment. for bash in general. But dialogue is another example where, you know, there's a number of options that have 2 dashes in the front, but there's probably some abbreviated ones also, maybe not. Actually, they may only have double dash options. So how do you know? Look in the manual page, right? And that'll always tell you how to run a command. All right. So grep is another case where we can use regular expressions, but it's still not the most useful case. The most useful case is going to be a command called sed. And sed is going to let us substitute one pattern with another. And we can do this in VI also. We can substitute one pattern of characters with another by doing something like this. So let me look for an occurrence of the word war. So I could substitute war with uppercase war. And here it found, you know, WAR and replace that with another pattern, in this case, uppercase. I could say $1, $, substitute lowercase WAR with uppercase WAR. And it will make that change multiple places throughout my file, 12,000 substitutions. And so this is going to be where regular expressions become really powerful, because not only can we replace an old pattern with a new pattern, but we can take the parts of your input that match an old pattern and do things with them. We can say, you know, match this followed by that, and let's swap them. Or let's take this followed by anything followed by that, and let's just get rid of the stuff in between and replace it with this followed immediately by that. And there's going to be lots of ways that we can use these regular expressions to do all kinds of editing and manipulation of files. And that's really where regular expressions become powerful. And we're going to do that through this command called sed. So that's going to be mainly what we talk about on Thursday, other than PA5. So we'll go through PA5 first, and questions, and then we'll start digging into sed and more regular expressions. All right, that's all I got for today. Hope everyone has a great afternoon, and I will see you next time.
See you.
See ya.
Bye.